everybody. My name is Lev Rosenthal, and I am with Slalom. I'm a practice area lead for our software engineering practice for our New York City market. And today we'll be talking about communication design patterns for microservices. Before we get to the fun part of this, we'll quickly run through introduction to microservices and running them on the multi-cloud and hybrid cloud environments. And then we'll get into scaling, patterns, and communication. And these are the fine folks that we'll be presenting for you today. And we'll introduce ourselves as we go along. So as far as microservices go, so the introduction of microservices architecture patterns has been basically described as running, representing an application, sometimes very complex applications, as a series of services which are loosely coupled, which are independently deployable, and which might be used by or built by smaller teams. There's definitely more things there, but as as I said before, we can talk about the kind of details of this kind of basics offline after the presentation. As a company or a shop moves from old monolithic applications into microservices, good experienced enterprise architect or enterprise architect group would be kind of on the lookout for some anti-patterns, which are very easy to get into as traps. Examples of those would be running or moving to microservices just for the sake of moving to microservices. That never works out. It has to support either some business goals or build some efficiencies or stability for the application. Another example of anti-pattern would be focus on technology, again, as opposed to business, or kind of getting into technology where smaller groups will go after different microservices in the context of the same application or the same offerings, and ultimately kind of without an architectural oversight, a strategic oversight, will kind of use different tools, use different approaches, different best practices, and is going to catch up with a group of developers very, very quickly. Decomposition approach, it's something that, again, architecturally needs to be done for large applications. And there are a couple of approaches there. One is kind of purely by business capability, and another one is by domains. And for example, for domains, if you're running e-commerce shop and you have a custom build application, you would maybe separate the application by domains of shop and browse versus checkout versus account management versus user management. That would be the example of the decomposition. Again, it's good to have an approach which is kind of adhered to and agreed upon by the team. And then last but not least, test automation. As a company or a shop get to the point of deploying services independently with having a pretty complex backlog, creating test automation framework is of absolute importance. This way, kind of ensure that the application is, has ample uptime, has good numbers in terms of performance, in terms of scalability, and ultimately keeps developers honest. And as an example of kind of moving from monolithic architecture to microservices, we'll quickly run through kind of a somewhat typical path which we see a lot in our clients. So in here, you see a couple of data sources, a couple of applications, and end users which use them directly. What we usually go for in the very beginning is kind of taking care of the right side. So instead of kind of users who use a specific application, what are the roles? What are the needs that the software is trying to fulfill? And again, we just have a few examples here. The biggest point here is that API gateway will take care of access concerns, permissions concerns, and very importantly, it would take care of API contracts. So the idea is you create the contracts that your users will ultimately expect, and this will allow you to go and start having fun on the left side with your applications when you may Dockerize applications, start creating separate services, start creating pipelines, which again, this context is still on-prem. Then you might be adding cloud offerings, and again, maybe just pure containers, maybe using some serverless offerings, but ultimately you may get to the point where you have multiple cloud providers. It may be on-prem, maybe not on-prem. That's really up to you, obviously. But the most important part here is the gateway will hold those contracts where no matter how many changes you make on the left side, the consumers will not be affected. And hopefully the only change they would see is difference in fixing problems, better performance, and a quicker path to market for new requests. This is it for the journey, and I'll hand over to Mona to talk about scaling microservices.
Thanks, Lev, to giving a big overview on the microservices. Hi, everyone. This is Mona, solution architect for the New York City market with the Slalom. So I'm going to deep dive into the scaling microservices. So Lev, if you can go to the next slide. So basically, before getting into the scaling of microservices itself, let's a little bit talk about the scale cube. So the scalability cube is basically composed of the x-axis, y-axis, and z-axis. So what are those axes? So the x-axis is basically a traditional way of scaling or running multiple copies of the services or applications through a load balancer through different servers. What is a y-axis? So y-axis scaling is basically break the application into multiple components, modules, or services. So that general approach of the microservices is basically a y-axis scaling. And what is a z-axis? So z-axis is basically an approach of the x-axis and the y-axis. But where we are going here, we are going to provide a subset of the data rather than the application as a whole. So that's the z-axis scaling. Now, let's talk about a little bit more monolithic scaling. So what is a monolithic scaling? As a scalability queue, the x-axis is basically a monolithic scaling where the IT infrastructure is basically whenever the demand spikes for the application, the whole application had to be multiplied to the different servers or different server or different virtual servers. So that's a monolithic scaling. Now talk about scaling in microservices. So the microservices has own benefit, but it also has a complexity of the scalability. Whenever we basically the microservice, it has its own benefits, but it has also added level of the complexity, because not microservice, it's maybe when we write a microservices for a different component, it's not written into the same programming language. It's written into a different programming language, loaded on different hardware, running on a different hypervisions, deployed across a different cloud. So that's more complex than the simple monolithic way, because then we have to scale it up and down or in and out both the ways. But again, if we use the microservices, then if we use the scalability cube of the Z index, then we can scale it probably very nicely, because it provides the subset of the data. Say for example, if we have a different customer types, say for example, free versus a paid premium customer, then for the free instead of free customer, if the premium customer will get the more bandwidth of the services. So that's how we can scale is better the microservices. Lev, if you can go to the next slide. So when we talk about the scale of microservices, so there are three key points to scale microservices. Using these three key points, you can scale it better. So first key point is environment assessment. So you cannot just do a scaling of the microservices. You need to refer the conditions at the institution. Those are the external to the users, but effective for the organization in terms of limitations of the scaling of the different cloud and also a cost assessment. So you have to keep that in mind when you do scaling up or down. Making a strategic choices to the support vertical scaling because you can scale what is a vertical scaling. So you are adding more power to your existing machines. So when you scale vertically, it's often called like up or down. So when you refer to vertical scaling, then you are adding more CPU memory and resources to the existing server, or replacing one server to a more powerful server. But the cons for the vertical scaling is when you add more power, it's probably there is a downtime for it, because you cannot just add existing instance with the more power. So you might need to replace the instance itself. So there is a downtime for it. When you are so the third key point. So when you have to do a horizontal scaling, so the horizontal scaling is where you are replicating the machines or the microservices to the machines. So that's basically you are scaling out or in the microservices. So what does that mean? Like, so you are provisioning additional servers to meet your needs, often splitting workloads between the servers to limit the number of requests for individual server getting in. So that's how you are scaling it horizontally. So in practice, the scaling horizontal is usually the best practice, because as I mentioned while talking about vertical scaling, that usually the vertical scaling has probably a downtime. So you need to make a strategic choice. So when you are running like jobs which needs a more power, but that can handle the downtime, then you have to go with the vertical scaling. But when you are doing some kind of B2C services or that kind of, which needs always availability, and you can't afford the downtime at the time, you have to go with the horizontal scaling. Lev, can you go to the next slide, please? So the ways of scaling the microservices. So generally, all the clouds provide three ways to scale it: the manual, schedule, and automatic. As named, the manual is the manual, like the engineer needs to just click the button, but they have to do it manually. So they have to keep eye on every instance, like what gets spikes and where they need to increase the power. So that's a manual way. It's a good when you have a scheduled job, where like, okay, you have to give boost to your jobs. But in that case, if you forget to put your instance down, then you might lose a cost. The second way, it's schedule. This schedule is basically when like you have some big data files are coming in that needs a more power, and those are coming in particular some days. At the time, you set it up, the scaling in and out, or up and down based on that schedule. So that's a schedule way. And the automatic is basically when your computer database or any storage resources scale automatically based on predefined rules. For example, when metrics like memory or network utilization rates go above or beyond, then you set up your scaling of the microservices based on that. That's an automatic way to do it. Now I'll hand it over to Varun for the design patterns. Thank you.
Thank you, Mona. All right, so now that you've figured out how to go ahead and get your microservices, you can run them on-prem or you can have them running in the cloud. you also need to figure out how do you get there. Lev and Mona have discussed about moving on to the cloud and also the scalability of all these designs of moving into the cloud with the microservices. But how do you get to the cloud and what are the design patterns that can actually assist you getting onto the cloud? So we'll just go to a couple of them and figure out how to get through that process. Lev, do you want to move on to the next slide? Every organization that exists, they always suffer from Conway's law. And this is something you could go ahead and search all over the internet. Every company has their system set up in the way the organization's communication structure is there. There are ways that we can go ahead and avoid it. And there are ways where we can try to fit into it and see if we can build systems around so that it supports the whole ecosystem the way we want to do it. Can we move on to the next one slide? So if you have an existing application that you would plan to move from a monolith to a microservices pattern, or you're starting fresh and you want to come ahead onto the microservices ecosystem for a new system that you're building, the very first thing that you need to identify is your business service decomposition, what the process is going to be, how your services are going to be. So you would want to go ahead and analyze what are your domains that exist in your system, like Lev and Mona mentioned about about your billing services or your shipping services or anything else that exists part of it. What are the business capabilities you want to entail within your service by itself? What are the boundaries of your applications that you want? When you go ahead and you chart these pieces out, you will be able to have a domain-driven approach to what your services are, and you will be able to define what the different services exist in your ecosystem. Once you have a map, a mind map of all these services, all the capabilities and what the domain exists in your ecosystem, you would be able to draw lines on where your microservices should reside within. Lev, can we move on to the next slide? If you are coming from an existing application, and it's not easy for us to just go ahead and just blow out existing what you have and start it fresh. So there are different patterns that exist in the ecosystem to kind of understand how would we get there. The two main common ones are the strangler pattern and the anti-corruption pattern, anti-corruption layer, which exist. Strangler is basically, think of it as a big old oak tree, the way Martin Fowler puts it, on a fig tree, where you have these big trees and these small trees, vines growing around it, which slowly strangle the big tree, and then take over it completely. So you would have small microservices which would come along the way, and you would strangle your monolith piece by piece into smaller fashion. At the same time, you can't just have things into your in your monolith without having disruption coming along the way. So you start creating anti-corruption layers between the two systems, which allows you to go ahead and build them in parallel without compromising any existing designs or technological approaches that exist for that. Lev, can we move on to the next one? Thank you. You will have different communication styles once you come into a microservices ecosystem on how these different services will talk to each other. Some of them could be just API gateway communication with REST and gRPCs. You would have a backend for front ends where you would have a unified front end with multiple services in the back coming together and communicating. Some could be just backend services talking to each other using messaging with AMQs, Kafkas, RabbitMQs, and all the other bus services that exist out in the ecosystem. Some of them could be just domain specific, where you have emails coming in or you have video streaming options coming through where you would go ahead and share the information or communicate between your different services. The old school system of file drops over FTPs or S3 buckets or anything else, also one of the ways that your services can communicate to each other. So it could be a service to service based communication or a service to user based communication. Can we move on to the next slide, Lev? Thank you. Once you've identified your services, you've got some patterns on how you want to do your communication and how your service boundaries are done. You also want to identify how does all this data that comes into your system needs to be managed out. There are different patterns that can work for your benefit or how your ecosystem has been built. There is no single point solution which works all for. So you could pick up an application where you will have a database which is per service based. The data for one particular application could be isolated in that database by itself, which could be for security reasons, could be the volume of data, or just for scalability standpoint. Some cases for cost constraints, for licensing purposes or legal constraints, you might have a shared database where you would have data coming in from different sources, fanning in and fanning out from a different one. You have saga patterns where you have services triggering downstream services and having the whole data set to come out as one big pattern at the end of it. You have an API composer, which is very common to use on the UI applications. When you have a mobile app and you have services streaming data from different APIs and different sources, then you compose all of them together to come back to one service. on one place. And then in the end, the event sourcing point of it for data management. When every time you create data, you want to handle it through your Kafka pipelines or your AMQs, and how does the data flow through that, and how the data management happens is one of the processes you could think of. Lev, can we move on to the next one? Thank you. Deployment. So now that you have built the system, you've identified, you've got your whole data management, let's talk about deployment, going to production. If you are on an existing on-prem system, you could think of the old school style of having a machine per host, which is not a very viable option going. As you add more and more services and scalability becomes an issue. If you are still on an on-prem, have VMware, then you can have a service per VM, or come on to the new school style of using stuff with Docker and Kubernetes and allowing auto scalability and have containerization for your whole ecosystem. AWS, Azure, and GCP offer good options for serverless. So you could go ahead and explore them, where you don't have to worry about the whole ecosystem of setting up your backup, your containers or your VM or any of the dependencies that come along with it. Just write your fragment of code, put it on the serverless, and you're hitting production within a few minutes and getting your service up and running. Can we move on to the next one, Lev? So now that we've spoken about this, let's talk about how these microservices can communicate with each other. Ankur, over to you. Thank you.
Thank you so much, Varun. So good afternoon, everybody. My name is Ankur Sinha. I am the solution principal at Slalom NYC, and I'll be talking about microservices communication. I think now that you guys have understood that what are microservices, how do you get into cloud, how do you really scale them, and then talking about the various design patterns that Varun talked about, and Varun really presented that. We are in the cloud, we are running it. Lev, can you move to the next slide, please? So now we are running in the cloud. And our microservices are growing, and they're growing on a crazy amount because you're coding microservices for every small business domain specific requirement that you have. Now you get something like this, the picture which is on the right side. You'll think, how are these microservices going to talk to each other or going to talk to the clients? So usually what people really end up doing, or what we have seen at our clients that they end up doing, is they put an ELB because that's the easiest solution to put in front of the the microservices. Now you have a load balancer managing that load for you, and you're just communicating. However, there's a lot of the things that is happening in the background when these microservices are talking, not just from external clients to the end of your backend services. Also, when the data is being transferred between these microservices. So the microservices traffic is usually in and out, which is also known as north-south, and it is in between as well, because the microservices are communicating with each other, which is called east-west. Lev, can you move to the next slide, please? So for north-south traffic, the ideal communication style, which Varun also talked about in one of his design patterns, is API gateways. What we have been doing since the microservices concept has been introduced is that we put API gateways such as Apigee or Kong in the mix, and we try to handle the traffic which is coming from our external clients, from the client applications. And API gateway becomes that single entry point for every microservice calls, and it is routing the traffic to the specific microservices. So it's not just doing the API route, the traffic routing, but it also takes care of the security, the rate limitation, and some of the other good stuff which the API gateway will offer. So can you move to the next slide, Lev? Yeah. So now then when we handle this north-south traffic really well, we have now microservices communicating with each other. How do we handle that? And the most famous design pattern for that is a service mesh, because service mesh allows you to communicate between these services by decoupling and offloading most of the application network requirement. How it does it? It follows a sidecar pattern for that. What is a sidecar pattern? A sidecar pattern is really for inter-service communication, which takes care of monitoring your security-related concerns, and it abstracts all of those needs by keeping the business logic separate from your network-related communication information. So that way you are able to monitor your microservices better. So now, at this point, you would ask a question about, so why service mesh is only doing east-west, and why? Because it can do a lot of the things which API gateways are doing. So Lev, can you move to the next slide? So this is the reason why. So because what happens is that API gateways, is really handling all the API related calls and the business functionality, which you can code in your API service. And it is really abstracted away from all the business logic behind, but you can still have the business logic for specific for your microservices, which can be there. But Service Mesh really would handle all your network related, all your traffic limiting related requirements that it will do. And these can work together. So if you can see that API Gateway plus Service Mesh can provide you a greater microservices ecosystem. Can you move to the next slide, Lou? So yeah, so this is what we had, and this is some of the appendix that we have put, and there is a sample app that you guys can go and check out, and also some of the reference links which we have put together. We can move to the next slide, Lou. This is it from our side. Thank you so much for attending this session, and we are open for the Q&A now. Thanks.